This is the first SPSS demonstration under the unit non-parametric procedures, EACS 6023, Applied Quantitative Research Methods in Educational Administration, University of Oklahoma. In our video presentation, we had begun an introduction of non-parametric procedures using the most commonly used non-parametric procedure, chi-square, and we talked about two categories of chi-square: the goodness of fit analysis and the contingency analysis. And we had exemplified the goodness of fit analysis by bond issue elections across month, and we tested using a chi-square statistic. We tested as part of that presentation whether the incidences of bond issue elections occur randomly across the months or in some other non-random pattern. So we're going to focus this presentation, SPSS presentation, on the goodness of fit analysis. We are going to use the database that we've been using frequently for the course, the test scores database through SPSS, so you might want to get that database up and running. And what we're going to do is we're going to exemplify goodness of fit. Now, goodness of fit is not a real common type of analysis in the literature. By far, when you see chi-squares being reported in the literature, you're going to see contingencies much more frequently. Goodness of fit is kind of a limited type of analysis, but again, going back to our bond issue election analysis that we demonstrated in class, it does have some usefulness to it. So I really just wanted to use SPSS and show you how to perform a goodness of fit analysis in SPSS. Now with SPSS, the goodness of fit analysis and the contingency analysis are really quite different. I've always thought SPSS was a little bit strange in how it handled non-parametric procedures, but we'll go ahead and demonstrate both anyway. And in this video clip, we're going to demonstrate the goodness of fit analysis. So looking at your test scores data set that you should be familiar with by now, let's assume that the researcher just is interested in assuring that his sample has a pretty equal representation of male and female students in the data set. So this researcher is simply going to test whether the frequencies of males and females represented in the data set are equal. Of course, you can start by looking at the frequencies and seeing how close the frequencies are together, but you can actually test to see if they're statistically different or statistically the same using the goodness of fit chi-square. So we're going to assume that we want to test for a 50% representation of males and a 50% representation of females. So looking at our data set, first of all, let's do the descriptive statistics, which is simply frequencies of males and frequencies of females. And I'm going to use the analyze command, which is, as you know, our command that's most commonly used in SPSS, or at least it's the command for the different types of analyses. Under analyze, we'll go under descriptive statistics, and then go ahead and highlight descriptive statistics, then move over to frequencies and click that. The variable that we want to use, we want to scroll down to gender, put gender in the variable set, and the only thing we want are frequency tables, so we don't have to worry about asking for other statistics. So hit OK. We should get an output file. Let's see if I can get that a little bigger for you. And as you can see, we had 2,133 subjects in the data set. None of them were missing. And as you can see, the frequencies of male and female are not that far apart. Looks like 1,077 males and 1,056 females. That's 50.5% male, 49.5 female. So there's only a percentage point difference between the two. However, we'll go ahead and test it to see if that's a statistically significant difference, just to show you how to do the goodness of fit analysis. Who knows, with this type of power, we might even find something, although I seriously doubt it. So now we're going to test that 50.5 versus 49.5 percentage statistically. Now for the goodness of fit analysis, we actually go back up to the analyze command, and we're going to highlight non-parametric test, which is used for the goodness of fit model, but not for the contingency model, kind of surprisingly. But highlight non-parametric tests, and then go over and highlight one sample, because we're looking at, again, we're not comparing two groups, we're just looking at the groups of males and females within that one variable. So highlight one sample. It should start off, you should have three tabs up there on the top: objective, fields, and settings. With objective, very often I would just leave that first radio button highlighted, automatically compare observed data to hypothesized. That tends to work just about all the time. For fields, well, the test fields has already defaulted most of my non-parametric data, so I'm just going to go ahead and highlight all of those, send it back over to the box on the left. Go ahead and just highlight gender, send it over to test fields. That's all I'm interested in testing right now. So it's going to test gender against a 50-50 criterion. And then under settings, there really isn't anything that I need to highlight under settings for this type of analysis. So I'm going to go down and hit the run button. And it hypothesized, as you can see on this lower box, it hypothesized probabilities of 0.5 and 0.5 with a one sample binomial test. And this level of significance looks like it is 0.665. It's not 0.05 or lower, so there is no statistically significant difference in the frequencies of males versus the frequency of females in the sample. So I would not reject the null hypothesis in that case. So that's a demonstration of the goodness of fit analysis, which is one type of chi-square analysis, which is a non-parametric procedure. In the other SPSS demonstration, we'll look at a contingency analysis.